Well, hello again, juniors. My gosh. You're probably wondering after that video, what on earth was he talking about? Where is the spreadsheet? Well, you were supposed to just imagine what that spreadsheet looked like. Ha! Just kidding, of course. Actually, the spreadsheet I was most interested in you looking at first was this one. And this spreadsheet is the one that's up there in Classroom. You can download it. It's actually an NRCS spreadsheet they use for soil texture triangles, and it's really, really, really cool. I mean, every now and then you run into some spreadsheets that just really, really make you feel good, and this is one of those spreadsheets that makes you feel like just makes you feel good. So if you have a sand, silt, and clay fraction, which you all do, and remember you've got 3 sand, silt, and clay fractions, or combos for each of the 4 sites. So you have 12 of these puppies, right? My guess, my suggestion to you would be to produce 3 of these triangles, 1 or 4 of them rather, 1 for site 1, 1 for site 2, 1 for site 3, 1 for site 4. And you're going to use the first 3 of these. You won't probably use the 4th one, but you would use for sand, for instance. Let's say you had 10% sand and you had 30% clay, and it'll automatically calculate your silt. But look at that. Look at that. See that? Look at that. Isn't that awesome? It just plots the point for you. Fabulous. If I did that again, this time let's do 100% sand. You'll see it down there, right down there in the corner. And then if we did, if we had one that was like 50 and 40 clay and then 10% silt, and look, bam, there it is. Hopefully your 3 points at each site, for let's say this is site 1, hopefully your 3 points won't plot like that, because that would be ideally, hypothetically, they should plot all in the same place, right? So let's hope that's the case. Anyway, well, then you can take and screenshot this puppy, right? So grab this with a grab. If you're using a Mac, you'd use Grab It. If you're using a PC, it's Snippet, whatever it is, snipping tool, and grab it, copy it, paste it into your document, give it a figure caption in APA format. Boom, you got it, right? So the goal here again is to look at each of the sites and their soil texture, but also while you're doing that, comparing your methodologies and how accurate they are compared to each other. So they should all come up with the same, they should all end up with a clay loam, for instance. If they all plot in that area or somewhere in that vicinity, they shouldn't be spread apart like this. So I look forward to seeing what you come up with there. Now, that's that spreadsheet. The other spreadsheet was this one. And this is one that I created that I used to give to students, because all they had to do was put their data in. Here's your total mass, and then your different fee sizes and so forth. Then it converts it automatically to a percent. Then it automatically does the cumulative weight percent. If you see what's going on here, the percentage, of course, 100 out of 3,000 grams is 3.33% of the entire sample, -3 fee here in this example situation. And then so the cumulative weight percent for that one is 3.33%. The next level at -2, the cumulative weight percent is 13.33, because I take the 3.33%, add the 10% for the next fraction, and then they can do the total. So it's cumulative. I'm accumulating percentages, and it should all go all the way to 100. And I've conveniently labeled these as pebbles, sand, silt, and clay, and so forth. Okay, you'll see the first graph that I've created that automatically pops up here. Again, automatically, it's awesome. Is a bar chart, or a quasi-histogram. And I say quasi because technically speaking, it's just a bar chart. But anyway, that's the kind of thing you're looking for. And you can see the nice distribution, pretty normal distribution here. And of course, this is an example. So of course it's a normal distribution, because I try to make it a normal distribution as much as I could. It should also, this spreadsheet also calculates percent error, but because I didn't actually, it's an example, and I didn't actually have any loss, there's no percent error. The only thing that's different here, of course, is moisture content. Now, your samples were all 100% dry, or pretty close to that anyway. So there's no evaporated moisture content to worry about, so don't even worry about that. Now, Down here, you'll see that I made a graph of cumulative weight percent. So on the y-axis, you have your percentages, and the x-axis, fee size. And you'll note that it starts at 0, and then it should have some curve to it. I mean, it could be straight, but it should have some curve to it, and then eventually asymptotically reach 100. I say asymptotically. It will reach something close to 100. It doesn't keep on going forever, right? So, although technically, I guess it could. If I had sieves that were infinitesimally smaller as we kept on going, we'd probably still have, at some point, particles would stop passing through, but it would look very asymptotic. Anyway, that's a fun discussion for another time. Now, how do we do this? So, I think you did see in the other video how I read off of this graph, and the main thing is that when you're calculating things like the sorting and the skewness, you'll note here that I have the equation put in here. It's the same equation that's in that lab that you saw in the other video. And all I've done is put the equation in there, and I've referenced the various cells that I need so that I don't have to keep going over and doing that over and over again. You'll see I've done that for every single one of the equations. There's one additional one I think I have in here, and that's sorting. You have skewness and kurtosis, but you don't have sorting. You could stare at this for a little while and see what I've done and figure it out, but it's not critical at this point. All right, so anyway, what I've done here is I've taken and written down what the various fee percentages are. I'm looking for the percent of sample that's 16 fee, for instance. So if I to do that, actually, this is a little misleading. This shouldn't actually be fee. It should just be 16%. Okay. So this is a little misleading. I'll go ahead and change it so I don't confuse anybody. But you see, these are the percentiles that you're looking at for these statistical measures. And so when you're looking at these, so you go to 16%. Let's just go with something easy. 50%, right? So I go over here to 50. There's 50%. I simply go along there until I hit where the curve would be. Then I drop on down and I read off what that would be. Now, obviously, for this particular curve, the answer is not negative. Oh, I'm sorry, it's not negative 2. It's 0.75. That's correct. So I've just typed in the answer. There's no special equations or anything. You actually have to read that off of the graph. And once you do that, though, with a spreadsheet, I already had it automatically set up so that it would calculate. And then I also had some really fancy if-then conditional statements like this one. Really proud of this. Took a while to put this together. Yeah. So anyway, you can check that out, but it's not critical that you do that. The bottom line is that when you look at the examples in your lab, you'll be able to come up with these examples. But again, there's these other graphs. Kurtosis is nothing more than the shape of the curve. So the skewness is whether it's skewed towards coarse or fine as the sample goes, and then the sorting is nothing more than if it's poorly sorted, it's a broad mix of sediments. If it's well sorted, it's mostly one thing. So if you have mostly -3 phi or mostly 6 phi, then it's poorly sorted, or it's well sorted. If you have a good mixture of everything, this is pretty much an example of that. So anyway, that's the kind of thing you're looking for there. Anyway, I hope this is helpful. Bottom line is your spreadsheet can look however it needs to. You don't have to make it look like mine. And I'm sure, in fact, I guarantee that some of you are going to make absolutely gorgeous spreadsheets that make this look absolutely miserable and boring. So please do it. Make your spreadsheet amazing, okay? Because I've already seen some good stuff coming along. All right, that is pretty much it, guys. That's what you missed. If you're feeling more fulfilled now, that's exactly what my goal was. So anyway, have fun working with it. As it turns out, this is January 30th, 2019 at the time of recording this, and tomorrow is, this year anyway, a snow day, which means that when you guys come back on Monday, we're moving on to a new activity. But Actually, I'm going to go back and do the solar activity from last semester. So we're not going to be working on this in class anymore. So have some fun working on it as a group away from class. So if you have any questions, email me, but email each other first and work through your challenges remotely. So much good research is done remotely. So just keep that in mind. All right, I'm going to sign off because it's 9 o'clock and I'm going to go and grade some stuff. Isn't that exciting? All right, talk to you later on. Have a great day off tomorrow.